So my name is Chilla Gal, and I'm also same class as my previous presenter, my husband. So, well, I'm an architect, and since I will be talking about the lasting impact of ESES on my life, not through my husband, but through my other baby, my thesis project, my dissertation that I just recently finished. So I decided we'll talk about how ESES influenced my dissertation and how the role of solar energy played out throughout the process of earning this advanced degree. So just as an introduction, not many people know perhaps that as a student of one of the first ESES classes with a handful of students and rather limited resources, what I walked away from ESES was a love of and a working understanding of solar and how to operate in a research environment with limited resources. So when I landed in Chicago in a similarly rather confined research environment, I rather felt home, and I started to develop my dissertation topic. During the 2000s, there was a tremendous amount of, well, not so, but there was a considerable amount of research coming which tried to address the issue of solar energy in a complex environment like cities. So I immediately jumped on it. This is something I want to do. So I worked on it. There was like 3 major universities that was working on it. Of course, Göteborg was more than the climate aspects of it, then Lausanne, and then also Cambridge, the Martin Center. So I looked at what they were doing, and I developed my own first, second, third proposal. Like I want to study how the built environment, different forms influence the radiative environment between buildings. I presented, there was lots of comments, questions, of course, from my advisors. But when it came down whether they accept my proposal, it was like, Chilla, you are narrowing down too much your topic. You're just concentrating on one single aspect, the radiative environment. You need to open up. It's much more to it. You need to look at the climate. So I said, yes, of course, I will look at the climate. So then, when I first said yes, I didn't know what I was getting myself into it, because apparently I needed to gain a basic understanding of atmospheric scientists and a working understanding of urban climatology. So what I learned from it is that they divide the atmosphere to different scales, the larger ones up to down to the micro and meso scale, which is eventually the interest of architects, planners, and most engineers. And what I also learned that as you come from the larger scales towards the smaller scales, the solar energy and the surface conditions play even more pronounced roles in what conditions we found there. So I just included one part of how they are structured, and but my topic was dealt with the influence of urban form, in my case urban block typologies, on the microclimate between building, which in climatology termed the urban canopy layer. So then I needed to decide what measures I'm going to be applying to. Temperature came naturally. And by digging through the literature and studying the urban climatology and urban human comfort, one measure that came down to it, so very important, was the mean radiant temperature, which is a theoretical measure. It's more like a concept of it, which unifies short and long wave radiations and its impact on the human body. So obviously that was my second choice of what I'm going to be measuring. And I chose my from my second hometown, Budapest, that as a concrete forms, and which later can be also evaluated on site. And as you might already suspect, the conclusions were, of course, when it comes down to climate between building, the major component is the sun, and in reference, and of course, the form of the buildings. And all other aspects that I also studied just came second, and so that's a whole a little bit of a circle that I ended up doing through my research. So, and this is where I would like to finish, and would like to thank all the professors and for the school for this lasting experience. Thank you very much.
I forgot the first time round, so Chilla, a little token of Congratulations and thanks for coming. So our third speaker is Stephanie, who will introduce yourself a little bit more.
Yeah. Okay.
And yeah, we're interested in listening.
Okay. So my name is Stephanie Köpsel. I finished the master's program in 2005. Right afterwards, it was very easy to find a job in Germany because PV was really on the rise. In fact, I applied for 3 jobs and I had 3 job offers. I decided to go with the company who produced thin film solar cells. In fact, I decided for them because they offered me a training in Sydney for 1 week, which was something nice to do. I lived about 200 kilometers south of Berlin in Leipzig, and next to us is a small village, and they had a lot of PV production. QSETs might some people know, and in fact it was also a bit of a crazy time because like everyone just wanted to produce solar cells because the feed-in tariff was very high. So this, for instance, was a company that had a small production, a small pilot line in Sydney, and then suddenly they just wanted to have a factory with really big PV systems. And in fact, it didn't work out. They went bankrupt as many others. However, it was a very, very important experience for me, just like to work in such a company. And my partner, to show our energy, I just put in some infrared images. I also got to know him here in Bollänge, but also a German. He started his own engineering office dealing with energy consulting. And since 2009, I'm also working with him. As I followed Mats as my big idol, I also have 4 kids, so I had some interruptions in between. And this is now our only way to, in fact, work in your own office with 4 kids. But this is just a topic that becomes more and more important. I just want to talk a bit about solar energy in Germany, and that you know what I'm talking about, just give you an idea of how much radiation we actually have and what the outcomes are. So it's about 1,000 kilowatt hours per square meter, and yeah, you get out about 1,000, it depends on the weather, between 900 and 1,000 kilowatt hour per kilowatt peak. And now we come to the reason why PV industry went down. These are the feed-in tariffs you achieved or you got for 20 years guaranteed in Germany. So 2005, you earned about 54 euro cents. So in fact, it was not about the ecological idea, it was more about earning money, and so many investors were just interested in. But this really went down, and when you look at now, you get about 12 cents. So it's not about feeding in the grid, it's now something different. However, what you can see, what really worked, like the system prices went down quite a lot in the last years. I just give you now a few of the projects we dealt with in our own engineering office. And this, for instance, was a feasibility study on 11 kindergarten buildings in 2010. You can just see completely different buildings, and they just wanted to know, okay, what can we do if we are interested in PV? What kind of installation can we have? What we learned in our engineering office, it's very important to really analyze the locations and also really go onto the roof to have a look. For instance, they had a solar thermal system nobody really knew about. So we were like, it would be hard to install PV systems here because there's something else already. But it's just the users sometimes don't know what happens in their buildings. They had a solar thermal system, but nobody knew about it, and they wanted to have a PV system, although there was not much space. So when you have a building, you just really have to look what happens there, what is there. What we did then, I think this was a good lesson I learned here was just analyzing the location. So what we also did here in the ESES course, we had a look on the horizon. So we just took like 360 degree photos, and then having the horizon line using PV-SYST, as we also used in ESES, for analyzing how much output they would have. And at that time, you still had quite a good feed-in tariff, and you could just calculate, okay, how much loss would you have due to shading, and how much you could actually get out of it. And with these results, we could just give them an idea how much they could actually earn with the greenish columns, and how much the installation maximum could cost in order that they would still earn money with their installation. What's also an issue, of course, in Germany as here as well, is the whole shading thing. So whenever you look at PV systems, you have to look what can you get out of it, is there any shadings problems? So you really have to analyze the whole roof area, you have to analyze the shading, and what actually happened because of the change in the feed-in tariffs, self-consumption is just a topic that's of much more importance nowadays. So it doesn't make sense to feed in the grid when you only get 12 cents, but when you pay 25 cents for the electricity. So the whole issue now goes more into storages, load management, and this is gaining importance. And what we learned is, like, you have to consider the entire building. It's not only about a PV system, put it on the roof and that's it, but you have to put the PV system on a roof, and you have to know how much energy do they need, how much of the generated energy they can actually use. Solar thermal, it's also for domestic hot water, or also, as we already talked, it's for supporting the heating system in Germany. This was also a project in Leipzig, an old house where the owner wanted to put some solar thermal system, and there we just were looking at optimizing what kind of system he could install, how big the storage has to be, just the influence of solar fraction system efficiency, just as I also learned here in the ESES program. And just the same, like when you look at solar thermal systems in Germany, you also have to look at the entire building. So you have to look how good is the insulation, what kind of heating system do they have, how many people live there, how much hot water they actually use. So that's why we came more to this whole issue of energy consulting. So now what we actually do is, looking at the houses, at the buildings. It's either just one person living there, or even houses with a lot of flats. And what we actually do is just first analyze how much energy they use, how much energy they lose also, like it's the roof, or like the outside walls, the windows, or the cellar. And then we just give them ideas what kind of redevelopment or renovating measures make sense. Like, does it make sense to renew the heating system? Or so first of all, we try to find solutions to save energy, and then we try to integrate solar systems or renewable energy systems, because that makes then much more sense. But the problem is, like, if you have a nice concept, it doesn't work if it just goes into the paper somewhere on a shelf. So we are more involved in quality control now, and to supervise the construction. So because a concept only works if it's really done the way you described. Very often it happens that then they have a plumber saying, oh, but I have the solar thermal package for a special price, even though it doesn't make sense to have that kind of solar package. So we are also doing measurements. It's a blower door test. You might know it's about air tightness. These are infrared images. This is how a German house look like when it doesn't have any kind of insulation. There are a lot of losses going on. This is how a house look when the renovation doesn't work out correctly. And as you can see on the roof, they had some problems with the air tightness, and so there was mold coming into, and now they have really big problems by doing the renovation in the wrong way. And so we just have now a much broader view on the entire buildings, looking more also into building physics, ventilation, humidity and mold problems. We do expertises, and what's also a big issue is subsidies in Germany, because we have like programs where the people can get very low loans, about 1%, but they have to involve energy consulting experts. So in order that they get the loans, they have to just employ someone like us, and they also get like half of the money back that we actually cost. But like German government just tries to make sure that when renovation measures in the energy efficiency are done, that they are done in the correct way. So that's also quite good, that you can even get half of the money from the state. So what we're actually doing now in our own engineering office is like analyze buildings, very thoroughly identify the losses, and propose energy efficiency measures, just as insulation, new heating system, and also renewable energy systems. We look at the entire building and its users, and provide custom-made solution as an independent expert. Just like we're not selling anything to the people, but just try to convince with our expert opinion what makes sense to be done. And this you can see maybe one of the projects. This was before the renovation. They put on insulation on the walls, and as you can see, the losses went quite down. That's it.
Well, sorry, one more thing.
Okay.
Thank you. Okay, so that I found really interesting, because it mirrors a lot what we've been doing in our own group, starting on some kind of technology, but then going to a holistic approach of the whole building, because this is what is necessary now. We now go on to Artemis Optikov, and he works at the company which is the most ESES dense company in the world, I would say. He's employee number 5 in the company, who've gone through the ESES program. I think you're only 2 who are actually working there still.
Yes.
And there was another guy who came for an interview or these discussions with them a few weeks ago. So that could be number 6 coming sometime soon. So, welcome, Arthur.
Thank you, Chris. Dear all, my name is Artemis Optikov, and I studied in ESES in 2010-2011. And I'm very glad to be here today during this nice celebration of ESES and SERC University. So, during the presentation, I will talk mainly about my current work, but I want to tell a little bit about my educational background and working experience after graduation from ESES. So I studied in Ukraine in Dnipropetrovsk National University, where I got a bachelor and master degree in renewable energy engineering, and it was quite a good start point to study in ESES. After graduation from ESES, I came back in Ukraine in 2011 and find employment with a big design company, where I worked 2.5 years. The main activity of the company is design of big gas and steam power stations with installed capacity from 10 to 700 megawatts. And since my favorite subject was heat energy engineering, I worked in heat mechanical department, and my main responsibilities were heat mechanical calculations and also performing of 2D and 3D drawings. And I also participated in developing a control strategy for power plants. It's one example of our stations. It's a big gas power station with 7 units, Siemens units, with total installed capacity is more than 300 megawatts. Now I'm working with Polysun simulation software, and it was developed in the Högskolan Rapperswil in Switzerland, and from 2006, spin-off company Vela Solaris developed this software. At the screen you can see a typical design of the system in Polysun with some components. It was to mention some main features and advantages of the software. So Polysun allows to simulate different components in the scope of one system. It means that both electrical and heat part can be simulated in one system. And plug flow algorithm and variable simulation time steps allows precise simulation of system with dynamical behavior. It's also a very user-friendly tool. It was translated into more than 10 languages, and it has wide manufacturer database from all over the world. I'm doing my PhD work there. My work is a part of Shine network, which is paid by European Union. And the main aim of my work is to extend Polysun to allow simulation of decentralized solar district heating systems. And like sub-aims, main sub-aims are extend building model to cover simulation of multiple residential units in scope of one system. Also need to develop new model for multi-thermal zone building. And at the end, I want to work also with pipe losses model. I work, my project duration is 3 years, and I work there for half a year already and achieved first results. So it's already possible to simulate in Polysun several buildings for the centralized heating system. You can see at the screen such system example. So that's all about my work. And in the end, I want to congratulate SERC and ESES with this double anniversary. And I want to wish you a lot of good students and fruitful research. Thank you for your attention.
Yeah, thank you very much, Artem. So, as I said before, one of the joys of working on teaching in this program is to see people, but it's always nice if you can meet them again. So Artem is also working in the same project that I'm working in, so it's actually really nice to meet up with them again. So this is a big benefit as I see it. So next up, also from Ukraine, Hanna, please go ahead.
Hello, everybody. It's very nice to see you all today. My name is Artemis Optikov. I'm also from Ukraine. I studied in European Solar Engineering School in 2011. Before that, I finished a bachelor and master program in renewable energy engineering in Dnipropetrovsk National University in Ukraine. So when I finished my studies in 2011, I found an employment at a PPC contractor company in Kyiv, Ukraine. And I was in charge for design of several large-scale PV power plants on-grid, ground-mounted, and also for a number of small off-grid systems. Then, since November 2012, I worked in the same company, Dnipro-Dnipro Energoprom, which focuses on providing design for mechanical and electrical design in the field of power and heat generation, mostly in CIS countries. So when I came back from Sweden, it was solar boom in Ukraine because really high feed-in tariff, which was called green tariff in Ukraine, was introduced. It was set at the point 46 euro cents per kilowatt hour, and it was 10 times more than the average price for electricity for households. And this green tariff is a subject for decrease during the time, and it is granted until 1st January 2030. So now it's about 34 euro cents per kilowatt hour, and from January 2025 it will be 24. So also in 2010, 2011 were also some land lease and tax-related stimuli introduced, which really helped companies to build PV power plants in Ukraine. And now we have about 600 megawatts of installed PV power plants. However, in 2012, local content requirement was introduced by Ukrainian parliament, and local content requirement is now 50%, which is very difficult to meet. That's why solar energy market is not developing at the moment. It's one of the reasons. So this is a map of power plants developed in Ukraine, PV power plants. So in total capacity, it's about 600, mostly developed in southern regions. Ukraine has very favorable conditions for solar energy, very high solar radiation. And I was in charge for design and engineering of those PV power plants. And the first my project was in Kherson. This is in gray color because it was only feasibility study. And then we designed 50 megawatts power plant, and only 25% were actually built and commissioned. And we now have lots of projects which haven't been built due to some legal reasons or lack of funding. So at the moment, the main goals of energy sector of Ukraine are to introduce changes and increase efficiency, and also to decrease dependency on Russian fuels, of course, and increase energy independence and energy safety of Ukraine. And Ukraine has to encourage the transition from gas to alternative fuel types, and also to increase energy efficiency and further develop renewable energy sector of Ukraine. So now since April this year, we live in this beautiful city in Winterthur, Switzerland, and I'm learning Dutch and looking for a job in this area. So I would like also to congratulate ESES and SERC, and I would like to also express my sincere gratitude to all our teachers who gave us high quality and relevant education, and helped us to start a professional career in the field of solar energy. It was a pleasure to study here. Thank you.
Thank you very much, Anna. So, yeah, next one. So, now we've gone through, a bit more than half. Next up, changing area of Europe is Maria. So, please, welcome.
Thank you very much. Hello everyone, I'm very happy to be here. My name is Maria, as you know, I come from Spain, and I was a very popular flamenco dancer before I knew from ESES. No, not true. And the title I chosen for this is The Quite Peculiar Life of Marilena Cantor Soto after her Duffy and Beckman revelation. And here we go. That was the revelation during my work in PSA, Plataforma Solar de Almería Research Center in Spain, beautiful, with a concentrating tower at the bottom. Yeah, so I'm not working right now in solar, unfortunately. I had to move from Spain during the financial crisis. And I'm living now in Switzerland, and I'm also looking for a job like Anna. And, but I wanted to tell you about what I did in Plataforma Solar of Almería, because after my thesis I was working as well there. And I don't know if you're familiar with this, but this is Almeria in the southeast of Spain. This is Tabernas Desert, and there are many Western films played there. Clint Eastwood, love it, and everything. But apart from that, there is one famous research center there, the largest in Europe, and I perform my thesis in the laboratory of optical characterization and decay of solar reflectors. You can see the sign over there. It's a very, very large center. So my thesis was about how to optimize the cleaning methods in order to reduce cost. Basically, normally CSP plants are washed, the mirrors are washed with demineralized water, and we wanted to demonstrate that with less quality water we could reach good optical performances as well. So yeah, the experiments were developed in this loop here, and yeah, here we are. We have here some pictures about the thesis. When I took the experiments, and basically it's based on how the reflectance was varying depending on the type of water, the quality of water we were washing with, in combination with other parameters like pressure or temperature. And finally, we had good results. We could reach good reflectance values, and in combination with a bit more temperature, we could reach very close values compared to washing with demineralized water, which was much more costly. After that, I got a job there, and I had a great time there, and I continue working in this laboratory. And yeah, these are a few pictures of the instruments we were using there. Okay, spectrophotometers, portable reflectometers. We could take measurements on site. With those chambers to simulate salt-sprayed atmospheres, weathering chambers to simulate several weathering conditions that would destroy the mirrors. And the main activity of the laboratory is to study how these reflectance, or how the mirrors decay during weathering conditions, and how will be the real lifetime. Recently we launched a publication. It's not really fresh for me, but yeah, by that time, that was 2 years ago, we did a study with secondary concentrators for Fresnel and for concentrating towers. And we took samples, and we used them. We performed several tests in laboratory, and yeah, there are a few tests here. Yeah, we put it in salt spray chambers. We had also muffler furnace, so we could put them in at temperature, constant temperature, and thermal cyclings to simulate day and night, and how the mirrors would get decayed depending on this change of temperatures. And we performed also some experiments in a solar simulator in Paul Scherrer Institute in Switzerland, and then we compare several materials. And we obtained some results, and maybe it's too long to explain, but what was for sure as a conclusion is that with damp heat simulation, we got the highest reflectance losses, basically. And after this period in Plataforma Solar of Almeria, I left Spain and I went to Iceland to work in an eco-village. Because since I was here in Sweden, I love northern countries. It was clear that I had an interest. And I work in a sustainable community, very peculiar, where there is about 100 inhabitants, and the 50% of them, they are disabled people who work and live there. And yeah, the philosophy is based on the reverse integration, which is the society adapts to the people with special needs instead of the other way around. And it's a small village who incorporates greenhouses, organic bakery, coffee shops, art workshops, so people can live and work there. And yeah, each inhabitant is working in one of these institutions of Solimar. This character is very famous in Iceland because he walked all over Iceland to gather some money to build a theater there in this eco-village, and he was very famous in the 80s. His name is Reine Pétur, and I spent most of the time with him there. So I've been the last 3 years there, the last periods, 4 to 4 months during the summer. And the first year I had the opportunity to work in this sustainability center. I was doing a bit of environmental education. And I also tried to gather some data from this PV hybrid system. There is also a wind turbine quite close, it's not in the picture. And in order to enable the possibility to bring a student, and as a student maybe to perform a thesis. It's a very interesting place where to live and work and have a great experience. And maybe, who knows, in the future is still some information available enough to develop maybe a master thesis. This building is very interesting. It's a sustainable building. It's made on recycled materials. Basically, all the wood, for instance, it's been gathered in the coast of Iceland. So everything is 100% recycled. And here I wanted to show a picture, a diagram about the ventilation system of the house, which I found quite interesting, and maybe maths as well. And I'm not explaining so many details because I know that it's going to be probably a bit long. And the last year I was working in the greenhouses, which means this summer, because there is 2 wells in Solheimar who provides hot water and district heating for the entire village, just 100 meter deep, and we get water at 86 and 92 degrees, and this is enough to supply hot water to create high temperatures in the greenhouses. Yeah, and what I did last year is that I designed a project to dry tomatoes. It was fantastic because nobody was drying anything there, and they had energy and they were not using for drying food and store food. So this is Reine Pétur again showing a tomato, fantastic. And this is the first prototype, the first design I did for the Go Drying project. It was a kind of optimized, and this is reality. So that was the result, but at least we could build something, a chamber, and last year was the first experimental drying there, and this year we could improve a bit more the chamber, and we could reach temperatures enough to dry tomatoes, because tomatoes need between 48 and 50 degrees to get dry. And I just wanted to show a couple of pictures of Iceland in case one of these students is interested in go and work and develop a thesis there. And I wanted to say thank you to all of you guys. Thank you to SERC and all the staff. I had a great year, a great time here. Thanks to Ghassan, as one of the students, he was feeding me the whole year, making dinner for me. And that's that was great, so I could study and I got better results than him, but yeah. And thanks again, it's nice to be here.
Yeah, thanks a lot, Maria. So, next up is Jonna, who's coming in to speak about what she's been doing.
No. I don't know. I'm the last one. I didn't see it. Okay. Hello, everyone. My name is Ioana. I come from Romania. I was in the ESES batch that graduated in 2011. I started in 2012. In 2010. So you've seen some of my former classmates here, Anna and Artem, and Bonnie is also here. So, I will give a short presentation about what I've been doing since 2011. First, about my ESES experience. I learned a lot in this year. It was a very intensive master program, very competitive, and it was also nice to have classmates from all around the world. We were the last batch before, as Frank said, the tuition fees for non-EU students were introduced. So I think we were quite lucky because we had the chance to meet a lot of people from everywhere. And I think in our year there were over 1,000 applicants. So it was a competitive program and a unique experience. However, it did not prepare me, at least, for the landscape change that was about to come in the solar industry. This is just a list I found of solar companies that went bankrupt in 2011 and 2012. So, yeah, I remember applying for a job at Solindra, and I was very excited about the position, but right after that I got an email saying, sorry, the company just filed for bankruptcy. So it was a difficult experience. And I decided, because I was unable to find a job in solar industry, I decided to specialize more in innovation management and intellectual property management. I went on to study another master program in innovation and logistics management at Dalarna University, and I also took courses from the World Intellectual Property Organization. This led me to an internship in patent and IP management at DHL in Germany. But eventually I came back to Sweden to work first for a company in Lund called Innovation Management. And I finally came back to work as a research assistant at the University of Gävle, where I am now studying a PhD. I think the beauty here is that I can also analyze in my research the solar industry from the innovation and intellectual property perspective. So I think not all is lost, but it was a very interesting and challenging experience for me in the past 3 and 4 years. So I would like to wish ESES and SERC a happy anniversary and keep up the good work. Thank you. This is the campus in Gävle. So, yeah. Thank you so much.
Okay, thanks very much, Jonna.
Thank you, Chris.
So what's very nice is be quite close to us, and I can see definite links in collaborating in the future, so this is really good.
Me too.
Okay, another one, I can also see possibilities for collaborating in the future is Bakram, who's living 3 hours drive from here, so you can explain what you're working on at the moment. Thank you.
Okay. Hello to everybody. Actually, I'm from intake 2008 and 2009, and what I can say, I came here to study when I was 41 years old. It means I was mature enough, and it is for me the second experience in studying. And actually, my first student experience in my first university, it was electronic based for 5 years. When I studied, it was absolutely another, not only world like universum. It is Soviet time, studying and participation in defense program is related to laser applications, particle weapon, and everything else. After crashing this and collapsing USSR, I participated in some kind of research in laser application, and I founded a company where I developed medical equipment which with laser applications. And I was like co-founder of the company and co-owner of company and vice president. But close to 40, I could recognize that it's some kind of my last chance to try something absolutely new. And I definitely recognize in that time that if I do not try it, I will regret about it the entire my life. The great people says, teacher comes when pupil is ready. SERC and ESES, it became for me that teacher when came in time to be able to change my life. And I sold all my business and I left my family temporary and I jumped into new reality. And difference between that world, it's really like difference between two universes. And actually, it's really funny. Became again student and jumped to like some young status. First 3 weeks, due to problem with accommodation, I shared rooms and lived in small room for luggage, sleeping on pumped mattress. And every evening when I'm going to sleep, I was thinking, is it worth to change my previous status of vice president, founder of business board in my country, for the student living like Carlson Potoket, almost. To be clear, to be honest, in that time it was not honest. It was not obvious. But now I can say, yeah, it was. It's extremely interesting experience, extremely interesting imaginations and some impressions. And I could compare approach to the studying, condition studying in my old previous life, because now 2008 for me it's bordered between two lives, previous and current life. And the same in Sweden, in Western country. I remember that I try absorb knowledge and courses as more as possible. 14, 16 hours per day, really, I remember. But I never was mentally tired. I like it, I really like it. Additionally to the SES course, I had courses from electrical engineering, and finally I got 2 master degree here after 1 year studying. It was really nice and feeling, because this SES community is some very warm community. I always feel myself very comfortable, like so comfortable. It's a lot of people from around the world. Very kind relation between teachers. It's totally new for me, and I liked it, really. I could get this chance, and I try use this chance. And really, I'm grateful, really grateful to SERC, SES, entirely to Sweden, and personally to Evelyn Berger. She supported me very much to be admitted, because 2008 it was the first year when Studer introduced. There were a lot of errors, mistakes, and I really could pass on the edge of knife to be admitted. And Evelyn Berger supported me too much, and I'm really grateful. By the way, 2 years ago I had chance and had with my family audience with Her Majesty Crown Princess Victoria, and I said the same. Thanks to Sweden that I got this chance, and what I can say, thank you. And that time which I studied here, actually, as I said, it's 14, 16 hours sometimes. From 5 o'clock up to 11 o'clock I studied. I did job every day, but I liked it. Probably that's why that time passed very fast. And exactly on the 1st April, I moved to Härnösand to make my thesis project at company Upsalicon. 2009, it was one of the deep bottom of the this world crisis, and I know that almost all companies stopped supporting any master thesis. And thanks to again to SERC support, they can find me the company with interesting task and project. It's company which located in Härnösand on the north. They produce concentrated PV thermal system. On that time, they starting like extending company when they passing from like research startup company to some kind of mass line production. The the major component of this system. It's this 2 meters reflectors, which they ordered production on some plant in Sollefteå. And one of the problem was tracking of quality. You can see that the focal line is very narrow, and it should locate in some specific place of receiver. In this case, the quality of surface and quality of shape becomes critically important. They tried to make some kind of evaluation using some kind of manual, this like shadow device or manual laser application. The idea which I propose, developing automatic system which can provide testing of device in totally automated mode, excluding any manual or human impact. I replaced solar beams to laser beams, and based on this idea, during the 4 months, it's from first idea up to installation in plant Sollefteå. It's over a 4 months pure job. I could develop. Of course, it is more related to my previous experience because I worked with lasers, I work with system. During my previous life, I worked and I learned a lot of additional fields, like basically I'm electronics, but I worked with mechanics, plastic productions, software, and basically on this, developed the system which works like that. You can install this trough, it automatically moves under line of lasers. One receiver comes inside with like 5 photo receiver from both sides on the same place where its common receivers stay and collect data about reflection. Finally, we have this image. Each cells, it is one cells with laser reflected. And we can evaluate the quality of, if it's black, there is no reflection. If it's red, it is on the edge, or green, it's edge. It comes, but it's not like PV, but only for thermal yield. Other thing, the different type of reflection which comes in necessarily place. Also, we have a system software produce Excel file which is works for calculation of percentage of how it works. Its system, as I said, totally automated. It go to the end and back. You can remove and store in database data of all troughs which pass this testing. It was really hard work, but I like it again. Developing something new, reaching the goals which nobody believed in reality. Even in that company, they never believed that I would be able to finish this project up to end. Moreover, I developed there two systems. This first one, this is second one for my second master thesis program from electrical engineering. It was a very hard job, but it was really interesting work. And I did everything myself. You can see that. Assembling, cutting, electronics, laser application. I had a lot of contact with Sweden University. They supported this project also. This contact I use still up to now because I have additional project with laser application with that company, with Sweden University also. And 5 years ago, exactly 5 years ago, I find job at company Sincere, which is located in Delsbo, close to Högskolan. The company is a world-leading manufacturer of non-destructive IR gas sensors. It is like expressed intelligent in small device. The major market for our sensors, it is ventilation, controlled after controller which evaluate the quality of air in any rooms. It allows sparing a lot of energy for heating and ventilation. But in most cases where OEM producers, you can open any Honeywell CO2 sensor and you find Sincere. if you open this Japan producer of sensors, Yamataki or Asbel, if you open the sensor, you can find sensor. 500,000 sensors per year. This is our IM production. This is one of the latest sensors, the world's smallest CO2 sensors. We get award from like King Academy of Science, United Kingdom for this innovation. Now we have new challenges for ethanol sensors because it's the very huge program supported by US government, and the fourth generation of sensors should be ready in the March, April to be installed on Volvo cars and future later. It is really a lot of science engineering work to be able to develop this type of sensors. The simple example, I think everybody knows how measurement now. You should make exhalation in the tubes when you measure the level of ethanol in your breath. But our approach is changed. Sensor can locate anywhere because once it was discovered that ratio between CO2 and ethanol in your exhalation always the same and reflect your percentage of ethanol in your blood. In this case, we can measure CO2 and ethanol and always found in ratio. In this case, our sensors can be installed anywhere in car. And the next challenge, installation of several sensors. In this case, the system would be able to define who is drunk, driver or passenger, and forbid engine starting also. It is next challenge. Another future application field that's for modern condition and cooling system is the next challenge, replacing freon to most probably pressed CO2 gases, because 100% CO2 is absolutely poisoned. One of our application, it will be alarm sensor for future car cooling system. Now we have negotiation with most famous producer of car like Audi, Volkswagen, Porsche, and also American companies. This is one of example for ethanol sensor. This is, you can see, we can make breath anywhere and it will reflect the percentage of ethanol in your blood. It is previous generation. Now we could make it significantly smaller and hope we can deliver first example for testing in Volvo, as I said, March, April. My participation, particularly in this project, developing a system which provide reference gas for concentration. Because the most important knowledge, it's like our company, let's say Dragon X, it's a system of calibration for any sensors. Because sensor itself, it is not so complicated device, but the most research, the most knowledge is expressed in system of calibration of each sensors. I can say that all equipment which we use in our production was developed by internal resource, everything, because it's extremely specific requirements. We cannot find similar equipment nowhere. We must develop it by ourselves. And my responsibility at company, it is developing of automatic system which for measurement, for production and for experiments, for research. This a few examples of so-called final test system. Because sensor presents itself like high quality, low cost supplier. And we should test all our sensors finally on final stage. This totally automatic station which provide testing. It is a combination of pneumatic, different gas connection, electronics, visual application which can recognize absence of any elements, and entire testing of sensors, because different type of sensor require different conditions for testing. This is my job, which I designed and developed, not all of them, but some of them. And actually, I like this job. I like the place that I live. Definition of happy man, as I know, it is that person is happy who every day goes to his job with joy, and every evening coming back at home with joy. I think I am that person. And it's end. Actually, okay, my current job directly not related to solar industry, but I try maintain contact with ESES and SERC, and 3 years ago I started giving some lecture about LabVIEW application, like LabVIEW application for solar industry. And last year it was a course for measurements. Also now we're discussing this course for this year's, for this intake also. Probably we'll have more connection for some research in future. We discussed with Chris also. And anyway, the time which I passed in studying, being in Borlänge, studying, it's amazing time. Sometimes I miss that time, my small room in Locus, and that hard working and studying. It's amazing time. It's that thing when after 20, 30, I hope, years, I will remember with some nostalgia. That's why I congratulate with this milestone, like 30 years and 50 years. It's great, really. I wish the best future, the best students, and the best opportunity cover the world by renewable energy system in the future. And thank you.
Okay, thank you very much, Bakram. So, last up of this batch of alumni is Desiree, who's now actually working with us again. So, please, go ahead.
Thank you, Chris. So, I was here in the year 2006 and 2007. And I wanted just to show, okay, I came from Ulm, I was studying electrical engineering there, and it's really in the southern part, so my title is From Ulm to Borlänge to Memmingen to Borlänge. And I did not know the future that I was going in this direction. So what I'd done as a master thesis here was like some other students, like working on the PV wind hybrid system from Frank. He wanted to research on that, and actually what I've done was to replace the wind turbine. So I was taking down that together with another student, and there was a charge controller, and it was NAPS standing on that. And on the research time, I wanted to have a look, how could I use that? And yeah, it's actually not NAPS inside, it's a Steka, and I did not know it is from Memmingen. So at that time I decided maybe I would try to apply after my studies here for that company. So just some short numbers. So it's Memmingen, it's 500 employees. We did. I'm not so long yet here, but we did research and development in products for solar, inverters, charge controllers, or controllers for thermal systems. But they also do some stuff like called white goods, which is consumer electronics for kitchens, and the urgent part was battery charging. And there exists, like over the years, this company as well grew, and they had went to Bulgaria because of some customers. So there are another 180 employees. I just want to show my nice colleagues from that time, and all the bunch is working on solar-related things like inverters and charge controllers. And it was really a nice group where we were working on different inverters. When I started as Steka, I applied, they were asking for software engineers and hardware engineers, and in the hardware engineer requirement was written minimum 2 years of knowledge in that field. So I applied for software, and I've got this small inverter, 300 and 500 watts, to improve on the software side. And it was an old invention from another company. Now I can say it was Philips that were working that, and they took it over. And when I now came here, it's really sad. They had, like, the age of this inverter is now over. It's like more than 10 years in the market, and then a certain time is over, you get problems with the components, so then they will let it die out. Okay, that was my first product for the inverters. And then the 10K, mostly we gave our products other names than the one which is on the catalog afterwards, so that was the 10K. And there I took part in development of some boards, and this was my actually first new product where I was working in with all of this bunch of new, really nice colleagues. So it is about 3 PCBs of me inside, and you can always see like such things like a part of you. And it was really interesting when I came here to Borlänge to work in SERC, and I got the chance to go to Glava. And all of a sudden, you find your own products where a part of you is in the real field. So at Steka, you sit on your desk and you think about things, but you never see it then afterwards in real life. You just see the mass production in the ground floor, but you never see how it is installed afterwards. So there it was the first time that I saw something from me, like working, and it was really amazing. So 2010, let's say like that, we came up with the idea to build like the whole team you have seen, to build an inverter which is totally, the casing is plastic, or like, you know, that's really massive. You need to lift it with 2 persons, and the idea was to create a new inverter totally of plastic, high efficiency, everything that it will work. And we're working about this inverter about 2 years, and then 2000, I think the first time would come out was 2011. So it was like 2009, 2010, and 2011 where we were working on. There was, oh no, it was 2012. So we came directly out in the crisis, let's say like that. And still, the market was really interested in inverter, and they said it is a good inverter, and I think we're still quite, maybe not number 1 on the photon, but for the range, the efficiency is one of the best ones. So after a while, the customers wanted to have also something like with IP65. So that's the one on the side. So that one was going forward, and after that they started to work on a 3-phase inverter, because all of those were like just single. No, it's not true. That's a single phase. That's a single phase. That's a 3-phase, and then out of that there came another 3-phase inverter. So up to that time, I was just working with inverters, and I really loved to work on the PV hybrid system, and I got the chance to work on the charge controllers, which is actually the thing that the reason why I wanted to start with the development of PV projects. And so before I was doing hardware, software and hardware, and all of a sudden they said, okay, we need a project leader. So that product is burning and we need that you run that as quick as possible. You should do it in 1 year. Okay, why not? Let's have a try. And I did not know what that will gonna be for me. So we were working really 1 year really hard to get this new charge controller, which was taking over the place from the old Tarom, which was used as well in the ESES program for a while. And I think the last project I was working on is, will come out. And the Q4, mostly Q4 means December. And that's a camping charge controller with 2 batteries. So Frank was asking me, you could tell what you have learned or what does ESES changed your life. So the thing is, I truly need to say, like the lectures did not help me so much on developing those devices. That was basically actually electronical engineering, components and how to use them. But it's more like the feeling and that we do something on solar. And the thing is also, I learned or I grew quite a lot here in Borlänge. It was amazing to be taught by all these teachers. The ideas came up a lot, but so they inspired on working on that. And it's some honor to work now together with all these former teachers. Again, so I'm back now to Borlänge and want to try to spread as well the spirit of solar. Thanks a lot.